Now this video is useful even for senior chemistry students in year 12. I'm sure if you show this the first time to them, there'll be at least a few things they've never seen before. But you're probably watching this because you broke one of the rules in my class, and I'm going to either ask you a random question from it or ask you where to, or both, ask you where it is in this video that you broke that rule. Okay? So number one, covered shoes. Should be leather, protects your feet. Safety glasses, if you're wearing normal glasses, that's fine. It's very rare. I don't enforce safety glasses, maybe for physics, electrical experiments. Okay. Lab coats, again, maybe just for physics experiments. This is mainly focused on chemistry. Maybe biology. Never sit on a bench. If there is a little bit of spelt acid, it will concentrate as it dries because it's losing water, and then you sit on a bench and you've got some chemical to slowly eat away and put holes in your clothes. All right. Hair tied back. I did have a picture of someone with a burnt face, but it's a bit too horrific, and YouTube wouldn't let me put that on there, most likely. Gloves, usually if there's an experiment that requires gloves, I just won't do it. And we're going to check safety risk assessments towards the end, which will probably be more useful to the year 11s and 12s because the teacher in junior science usually takes care of all that stuff and doesn't make a lot of mention of it. 3% is a good rule of thumb if it's greater than 3% concentration, like hydrogen peroxide, or 3 molar. Such as the acids, generally it's too concentrated, and we either need gloves or you just don't do it, or the experiment will work with less than that. Okay, food and drink, if I see it, it should be thrown in the bin. Could be contaminated. It seems like people have to have water bottles. You technically should wash your hands before using that and after an experiment. Sharp objects like glass pipettes, hold them loosely facing down. So that if you do get knocked, they drop and don't go through someone's hand. That's a fake picture, by the way. So don't eat, drink, or smell. Don't even ask to. There are occasions, some syllabuses have, syllabi have, you need to know the smell of ammonia and chlorine, so you'll smell them and waft them, so you dilute it, so you just get a general weak smell of it. Esters for year 12s, and I can't think of any other time. All right, so possibly never, okay? Never be asked to smell anything ever. Holding bottles by the lids, if they're not on properly, can cause a bit of a disaster if they break on the floor. Glass, this is probably the most common, putting stuff too close to the edges where they get knocked off. I shouldn't say that's the most common. Never sit during an experiment. Maybe that's the most common recently. If a liquid falls towards you, you have to move into it rather than away from it if you're standing. What's hilarious is how difficult it is to get a picture of people standing during an experiment that have glasses on and hair tied back. Go Google all the promotional pictures and everyone's breaking all the rules, okay? So keep chemicals below eye level, always fill or transfer like burettes. This one here, just generally don't touch anyone, try not to talk, only talk about the experiment. No, even something that you think is quite harmless, like throwing paper into a bin, just put it in the bin, okay? Any noise can cause or mask dangers or breakages. Generally keep things dry. I think that's the next slide, especially around electrical equipment in case it conducts electricity. Make sure you know the safety of the chemicals. That comes towards the end. Safety, and so you know whether you can put it down the sink or it needs to go into a waste container. I'll just go to this one. This one's a bit of a long one. Always keep this moving. Don't concentrate the heat in one place. It might crack. And when you're mixing, keep the opening away from other people. Just generally assume everything's hot. If you can't wait for it to cool down, just leave it on the mat on the bench. Let the teacher know just in case. If you must grab like the tripod, for instance, grab it down the bottom on the extremities. If you're really worried, you can wet your fingers and just touch it very lightly, and you can feel the heat without getting burnt. If you burnt or any breakage, just let the teacher know immediately, and put your fingers under running water for 5 minutes straight away. As you telling me that it, put your hand up or let me know something's happened. Always keep your bench clean. Give it maybe just with a chucks or a piece of paper that's lightly moist. Wipe it all down. Then you don't need to dry it, but you might need to dry it as well. That means that it's safe for the next group and they know what's there. Okay, so keep it dry. You don't know what chemical it is if there's some liquid on there. So keep your bench clean during the experiment as well. And so without saying, with all these dangers, it's pretty obvious, don't be in a classroom without a teacher, and don't do anything that the experiment hasn't asked for unless you've asked the teacher if you can alter it or do something different. Okay? Last one. If you have to clean up your glassware yourself, make sure you do a good job. If probably not a good idea to trust the other group that they've rinsed it thoroughly. So rinsing it with water or the solution you're using might be a good idea if you're about to do an experiment, but you need to know if that will ruin or help the experiment by having excess water or the solution in there. Okay, safety equipment. Eye washers, don't see much use for those really. Most taps point downwards. You just cup the water in your hands and you can wash your eye out with that. Probably more use for allergies. It's just JUST there. When you've got itchy eyes, that's probably when you're washing my eyes out, not actually a spill or anything, because you're wearing lab glasses, all right? Fire extinguisher, just know easily how that's used. It's pretty easy. It's pull the pin out, point the nozzle, and squeeze this part here to let it out. That should never be used. I've never seen anything that ever being used. Generally, if an experiment ever would require something like that, you just don't do these experiments, but it's all there. I'd never do an experiment that would have that much flammable liquid that it could spill on someone and then it could catch fire. There's all sorts of issues that would lead up to that should never occur. So I've never seen this needed. I did use it without it actually being used on an experiment outside, water on boiling oil, but I regretted using it. I used it flippantly because it's full of glass fibers and it'll make you itch. It's terrible. It has to be thrown away. So you're better off just using a wet cloth. Okay, safety equipment, shower. I think I've heard of a teacher using this because they spilt hot coffee on them. I'd never heard of it ever being used anywhere else for any reason. Any experiment that require that, I think for safety regulations, everyone must have one. Currently ours is just in the prep room, so every classroom has access to the prep room. But I've had them in individual classrooms, and I use them for egg drops because it had a decent basin, and so you could wash all the egg out when you finish. That's probably the only use for it. It's got to be there just in case someone spills soft coffee on them or something that's just never expected. I've never even heard that one being used except for once. Fire escape, this is probably, you probably have to be in Asia to know what that is and how that works. And then, okay, turning off the gas, there's the mains, usually under the desk. That's on. If it's down this way, it's off. There's usually some sort of electrical switch or a key with a red light. Every classroom I've ever worked in has the electrical board inside, so you can physically turn it off the mains or back on usually if it switches off for some reason. Sharps container, there's always a brush and a pan to brush it up. You've always put it in there, not into the bin. And of course, always let the teacher know that you've broken something. I've never seen this one used either. We'll never have super strong spills, but I've seen that happen in the prep room with the tech. Just put baking soda on it to neutralize it, or strong base weak acid. So the thing you're neutralizing it with is not a danger in itself. It's not a strong base or a strong acid that's neutralizing the vice versa. You can buy chemicals. I don't actually think they're sand, but I think we use sand. I think they're like clay, so it absorbs better, but the sand will be fine. I think they use sand. The fireys use sand if there's a big chemical spill on the highway. I think. All right. First aid kit. Cover any scratches. Even if it's a weak acid like vinegar, it's going to sting or hurt. If it's harmless, so cover them up with waterproof. Obviously, there's the blood biocontamination issue as well. You have to be lucky to have a fume cabinet. So if you've got a fume cabinet, you can probably do some more dangerous-ish experiments. Every room should have windows that open, hopefully, and so you can have good ventilation just for Bunsen burners. Okay, next is risk assessments. Now, you need to go to a good one. This one's risk assessed, but CLEAPS, the British system, is also good. It's got to be very, very clear. The CLEAPS and the risk assess are very good because they tell you exactly what year levels you're allowed to do it for if it's just teacher. They tell you exactly what all the dangers are and how to deal with things very clearly. Manual safety data sheets are not very good at doing that. They're very vague. And so always look through the chemicals that you're using before you do an experiment. These are the symbols. Now, these symbols don't cover cryogenic, such as, liquid nitrogen or carbon dioxide that can burn you. Sometimes in physics, we do have alpha gamma sources, but I don't like using them without a gamma counter. I'm not a physics teacher, so I avoid those. Electrical hazards are there all the time because we use power packs even for chemistry. Not really even for biology, and we're using data loggers. So we've got the laptops and data loggers out for all the sciences. And biohazards, even your spit, we're not allowed to do experiments. You're not allowed to use the spit in your amylase for biology experiments. That's considered a biohazard. So everything's considered a biohazard in bio, pretty much. That's not covered. They normally just do a warning symbol. And that warning symbol can be these when they're less problematic. So I'm actually making this video because I have to tell them what corrosive and oxidizing is, which is kind of the same thing as... but anyway, I'll do an experiment for that. So corrosive, it technically just means it's just damaging the integrity of materials. Usually it's like metals rusting, or your skin, all right? Which is usually also oxidizing. It doesn't have to be, so it's reacting with oxygen. So certain chemicals cause that oxygen reaction very quick, all right? There's 9 of these symbols. So copper sulfate's a big one for aquatic toxicity, but it can be lots of other things. Catching fire may not be a serious thing. So if the ethanol is in a burning container that's quite well sealed, technically the Bunsen burners. This I try and avoid unless it's just, it's just not that serious. Pretty much everything is a health hazard. Even the oxygen we breathe is toxic. It's got radicals. So you've got to look at the experimental evidence. If they've called it carcinogenic, you just still have to take a bit more of a careful look, or generally try and avoid it, even no matter how minor it is. But still need to look at the MSDS. Some things are way more dangerous than others. Toxic, generally never use. These 3 generally never use. Our current school is very sensitive about having any hydrogen gas or oxygen gas, even though I've asked for it. Most schools I've been at have that. Explode, I don't even know what you would do. I do create experiments that do explode, but not ready to explode. I put that in a situation. If you look at the butane bottle explosions, there's a safety thing, and I reinforce the bottles and all that sort of thing. And I've experimented with all sorts of different combinations as well. It can be quite dangerous. Toxic as well, avoid. So generally you won't see those. The teacher won't give you a situation where you'll be exposed to any of those. Okay, just lastly, international labelling. You can't tell if it's American or British system when they do the 1/6 or 6/1. So write your dates as 1 June 25. If it's 1st of June 25, that way no one can get confused on what the date is. Now the date's important because the chemicals can go off. So you really should say opened or received the date and sign it. And that's a proper labeling that no one really does, especially how accurate the concentration is, how many decimal places. I think I've never seen that. At best, you'll get the warning symbol and either the name and the chemical formula as well, hopefully both. You'll get these three. All right.